This is a platform favorite to the Java users. Deep Learning for Java, DL4J in short, is a suite of tools for running deep learning on the Java virtual machine. The only framework that allows you to train models from Java while interoperating with Python ecosystem. Yeah, it allows one to work from Java and using the Python ecosystem for building the models, training the models and all. So this DL4J has several submodules. Some of them are same diff, a TensorFlow PyTorch-like framework for execution of complex graphs. This framework is lower level but very flexible. It's also the base API for running on NX and TensorFlow graphs. ND4J is another submodule. It's a NumPy++ for Java. Contains a mix of NumPy operations and TensorFlow PyTorch operations built under this submodule ND4J. Then libnd4j, a lightweight standalone C++ library enable math code to run on different devices. It's optimizable for running on a wide variety of devices. Python4j is a submodule defined under DL4J. A Python's script execution framework using the deployment of Python scripts into production. That's a basically Java-based system. So if we are comfortable with JavaScripts, yes, we can make use of this submodule Java4J, and we can deploy Python scripts into the production. Apache Spark integration is provided, enabling the execution of deep learning pipelines on the Spark. DATawake, data transformation library, converting raw input into tensors suitable for running neural networks. So when the data is available, then the raw data, if you use directly, it's going to be tiresome. So very inefficient way of working. So for improving efficiency, the use of tensors is a must. So this DATawake is a library which is very much useful for converting data into tensors. And because once they are converted into tensors, running on neural networks, training networks, and all, any mathematical operations become very fast. So just as an example, so we can see how the DL4J can be used for creating a neural network. We have two inputs. We have a hidden layer and one output layer. And the hidden layer contains weights for each of the inputs. So input 1 has a weight W0, input 2 has a weight W1, input 1 in the W2, W3 are for another node, W4, W5 are another node. And then output 0, output 1, output 2 are the used for converging into final output. So here the input is known, output is known, so we can make use of supervised learning, update the weights, and get the correct output for the given input. So it's possible with the DL4J. We have many tools for such operations, so keep watching. Thank you.